Okay, we are ready.
Okay, we can start. Hello, everyone, again. Welcome to our session of our dissertation council. Today is February 12th, and our agenda is singular but significant. We are gathered to evaluate it and discuss dissertation of Kapar Anel. This dissertation is entitled Modeling the Process of Solid Phase Microextraction of Organic Compounds from Environmental Objects. The specialty code is 8D05301, Chemistry. I see we have reached the required quorum. And your scientific supervisors, Orozbayeva Dina, PhD, senior researcher of Kazakh National University, and Yasik Kozil, professor of Iowa State University, USA. The dissertation was performed at the Department of Analytical Colloid Chemistry and Technology of Rare Elements of the Al-Farabi Kazakh National University. Official reviewers, Akalbekov, name, what is the name?
Nurgali.
Akalbekov Nurgali, yes, PhD, excuse me, associated professor, chief researcher of the Engineering Profile Laboratory, Physicochemical Methods of Analysis of Korkut-Atak, Varda University. And Sagandikova Guliim, PhD, postdoctoral researcher at the University of Tübingen. It's Germany, Wartenberg, yes. Okay, and we have temporary members of the dissertation council. Wujin Lee, PhD, professor at the Nazarbayev University. And Yusong Lee, PhD, professor at the University of Nebraska-Lincoln, USL. And Daniel Snow, a PhD, director of laboratory services at the what is the name correctly? Docherty Water for Food Global Institute, Lincoln, USA. Thank you for the attention and participation, dear colleagues. And now the floor is given to the secretary, scientific secretary, to Professor Bolat Oralbekov for the presentation.
Thank you, Chairperson. Before I will give a short and brief introduction of the candidate. Let me a little bit introduce you about procedure, especially for our temporary members and the reviewers. Yeah. So I will share so this information. And according to our rules, which are approved by our university council and which is also approved by the Ministry of Education and Science of Kazakhstan. So our council makes a decision by secret voting. And here you see the possible decision. So the four possible decisions. The first one is to award the degree of doctoral philosophy. The second one is send this dissertation for revision. Видно, да, экран?
Да, видно.
And the third one is a recommend for a secondary defense of the dissertation. So the dissertation sent for revision if we will found during our defense a minor issues which is not significantly change the main idea and dissertation and so on. Yeah, you can see here the dissertation work is sent for revision if it contains minor comments on the text and so on. And we recommend for a secondary defense in case if dissertation does not fully meet some requirements but follow most academic rules. Yeah, so we can recommend for a secondary defense of the dissertation. Final one is refused to award in case if we will find during defense some violation of the principle of academic integrity, like You see here if there is plagiarism or serious problems with originality, logic, and reliability, and so on. Yeah, and also the most important things which official reviewers also vote and have the same weight as the votes of dissertation council members. The dissertation council members was already the list of dissertation council members was already mentioned by our chairperson. So this is and our procedure will take about 2-3 hours. Yeah, so please 2-3 hours, and please especially temporary members and reviewers, please participate until the end of our meeting. So thank you for this, and then please give me some opportunity to give you information about candidate. The candidate born in 1997. Her name is Kapar Anel Amangeldikeze. Completed her undergraduate studies at Al-Farabi Kazakh National University from 2014 to 2018 at the Faculty of Chemistry and Chemical Technology. And she specialized in chemical technology of inorganic chemistry. So she graduated chemical technology of inorganic substances. In 2018, she enrolled in master program at the same university, at the Kazakh National University, Al-Farabi Kazakh National University. But now she's specializing in chemistry and completed master in 2020. From September 2020 to May 2023, she enrolled for her PhD at Faculty of Chemistry and Chemical Technology at the same university, Al-Farabi Kazakh National University, and specialty was AD 05301 chemistry. The topic of her dissertation and advisors were approved by our academic council of our university on November 2, 2020. So, Kapar Anel's personal documents includes copies of her bachelor and master diplomas, a list and copies of her publications, positive recommendation reference from her advisors, and also protocol from enlarged meeting of department, and all other requirement documents in accordance with regulation of the Committee of Quality Assurance, Science and Education of the Republic of Kazakhstan. As a part of her dissertation research, the doctoral candidate has published 5 works, research works, including one paper in Q1 journal, which is Analytica Chimica Acta, indexed in the Web of Science, and 2 papers recommended by the Committee for Quality Assurance in Science Education of the Republic of Kazakhstan, and she has 2 abstracts presented in international scientific conferences. On August 28 this year, the previous year, 2024, Kapar Anel Amangeldikeze dissertation was discussed at the expanded meeting of Department of Analytical Colloid Chemistry and Technology of Rare Elements at the Faculty of Chemistry and Chemical Technology. In this meeting, 46 participants attended. The first reviewer, which was who was Professor Rolbekov, and the second reviewer was from the same department, PhD Khaysar Chukur. Both participated in this seminar, and all questions and comments raised by reviewers were properly addressed. As a result of this seminar, academic seminar, an universally recommended dissertation for defense. And protocol number 21, dated August 28, 2024, was approved by the board member and vice director of research and innovation of GAZNO, Jamila Matna Ajana. And on January 5 this year and January 10, by Protocol 12 and 13, the Dissertation Council scheduled the defense date, appointed official reviewers, and designated temporary council members. So this is all the information I have.
Yes, thank you very much. Are there any questions to the plot? Professor Bulat Uralbekov. If we don't have questions, the floor is given to the Anel. Please, you have 20 minutes.
Be 1 minute, please.
Анеля, попробуйте это на полный экран сделать.
А что сделать на полный экран? Я что-то потеряла презентацию, почему-то не открывается. Не то, что не открывается, она потерялась.
Мы видим. Вашу презентацию.
Там надо
видим.
вот этот значок нажать, или я уже не помню. Вот это внизу
F5 нажмите или внизу значок демонстрации. А, она не видит этот саму презентацию.
Слайд-шоу, может, у вас не видно, что ли? Нельзя.
Ну, вы можете опять закрыть, Анеля, и опять включить.
Ну или альт-табом поискать, куда девалась.
Ну, скорее всего, там просто два экрана у вас, и он на второй экран показывает.
Нет, только один.
У тебя на Маке или на Windows?
На Windows.
Тогда да,
В
F5.
общем, мы видим вашу презентацию.
Только
Ой,
надо
курсор видим. Курсор видим.
Все. Так, видите?
Да, вот теперь развернулась на полный экран.
Угу. Так. Dear audience, thank you for your presence here to listen my presentation about the modeling the processes of solid-phase microextraction of organic compounds from environmental objects. My scientific supervisors are Rozbay Vadina and external supervisors Yasik Adam Kozel. Volatile organic compounds are becoming increasingly important due to their impact on global environmental conditions and human health. Environmental monitoring is essential for assessing risk and addressing pollution, and establishing a proper system is a highly complex task that demands substantial financial and human resources, particularly in developing countries like Kazakhstan. And while the most analytical method for various organic pollutants are chromatography mass spectrometry system, the sample preparation part is very complicated and diverse. And heat-space solid-phase microextraction is considered as one of the most simple, solventless, can be automated, and achieving low detection limit at very low cost of analysis. This method is based on extraction from a gas phase with a liquid or solid sample by microcoating. But accuracy of any sample preparation technique, even for ESPME, requires optimization of extraction parameters depending on the sample matrices and analyte properties. Such optimization may include coating type and dimension, sample heat space ratio, additives, extraction time, and temperature. This makes method development very time and labor-consuming task. And optimization of SPME parameters using computer modeling can significantly reduce the time for method development, cost, and labor. And Komsol Multiphysics has gained attention for providing quick and cost-effective results to extensive experimental processes. The main aim of the research were to develop computational models of SPME VOCs from environmental object without conducting elaborative experiments. And the objects of the research were computational models of processes occurring during SPME of VOCs from air, water, and soil. And the main task of the research were to deeper understand the processes occurring during extraction and to develop computational models with these processes under various experimental conditions. And the main statements to be defended are the computational optimization of temperature and time of solid waste microextraction of VOCs from air can be achieved using prediction techniques of Fuller method for diffusion coefficient in air, LTPR indices, and Van Gogh equation for estimation distribution constant between heat space and fiber, and inverse gas chromatography for diffusion in PDMS with remissive injury between 4.5 to 13.3% compared to obtained experimental extraction profiles at 23 degrees. Increasing the coating air distribution constant from 1000 to 10,000 at constant temperature and diffusion coefficient in PDMS coating equal to 10-11 results in 43 increase of equilibration time. Southwards approach allows obtaining simulated SPME profiles of BTX from water by CAR-PDMS coating, which are closest experimental profiles compared to other approach with remissive endurance below 10%. Using vacuum and increasing stirring speed from 500 to 1000 and 2000 RPM allows to decrease equilibration time of benzene from water using CAR-PDMS fiber by 48 and 71% respectively. Equilibrium in the system of SPME of benzene from soil with vacuum can be reached 43 times faster compared to traditional SPME at all study distribution constant and sample masses of benzene extraction by CAR-PDMS coating. The first chapter is the development and application of the computational model for simulating heat space solid waste microextraction of organic compounds from air. This research was aimed at developing of SPME of VOCs from air using polydimethylsiloxane coating. And physical model of SPME from air considers the two phases in the system, air and air coating. And to model this process and diffusion of analytes in air, distribution coefficient between fiber and air, diffusion of analytes in the fiber should be known. And mathematical model considers the geometry of the sample, which in this case consists of three domains: air and a gas sampling bulb, fiber core, and fiber coating. And to describe the mass transported in system, fixed second law can be used. For ensuring modeling accuracy, several empirical methods for prediction of diffusion coefficient in air were estimated in the model, and these methods are Fuller, Shetler, Gidding, Kirsch-Felder, and Wilke-Lee. Comparison with experimental obtained profiles of diffusion of analytes in air are demonstrated in Table 1, where the percentage differences between predicted and experimental obtained values of dA were in the range from 0.5 to 7.2% with Fuller equation, from 0.4 to 18.7 with Hirschfelder equation, and from 0.5 to 11.7 with Wilke-Lee equation. And therefore, Fuller method was selected as the optimal for prediction the diffusion coefficient in air, as it is simple, it does not require additional experiments. Estimation of diffusion coefficient in the fiber was more complicated because no method can exist without relying on experimental data, and inverse gas chromatography was chosen for prediction of diffusion coefficient in fiber because it is simple and straightforward method. It can be done in any lab course with GC, and for estimation of diffusion coefficient in the fiber with AGC Gola equations were used in the model. Obtained DF values, experimental obtained DF values at different temperatures were linear, where S squared 0.9242 Luen and 0.9899 for other analytes, showing acceptable accuracy for use in CMP model. For estimation of distribution coefficient between fiber and air, two approaches were used: linear solvention energy relationship and linear temperature parameter tension indices. And for estimation the temperature dependence on of distribution constant, Van Gogh equation were used in the model. Different combinations of proposed methods were simulated to describe the extraction process, and to validate this result, experimental profiles of SPME were obtained experimentally using gas sampling bulb with PDMS coating at 25 and 40 degrees. And as a result, lowest root mean square deviations from experimental obtained profiles were in the range from 5.1 to 8.2% for benzene and toluene, 25 and 40 degree, obtained by DF values obtained by GC and KFA values estimated by LZR. For ethylbenzene and oxylene, lowest root mean square deviations were from 4.5 to 16.3%, obtained by IGC and LTPRI. And thus, a combination of IGC and LTPRI were chosen for modeling purposes because in most cases it provided the lowest RMSDs, or they were below 15% for all BTX at 25 and 40 degree, compared with experimental obtained profiles. The developed model was used to study the interconnection of diffusion of analytes in the fiber and distribution coefficient and their effect on the extraction process. And 5 different DF values were estimated at 1,000 and 10,000 kFa. And as a result, diffusion has a substantial effect on extraction profiles. It becomes a limiting stage in the extraction of benzene from air at lower kFa, for example, at kFa 1,000. 10 minus 9, when DF 10 minus 9, 80% of equilibrium amount is extracted in 6.5 seconds. To decrease this value to 10 minus 10, 5-fold increases this time. Where, for example, at KFA 10,000, similar decrease of DF increase only 43% in this time. And to conclude, computational optimization of SPME overseas from air can be achieved using Fuller method for diffusion in air, LTPRI indices, and Van Gogh equation for distribution constants, and IGC for diffusion in PDMS. And this approach yields RMSDs of 4.5% to 13.3% compared to experimental BTX extraction profiles in 25 and 40 degree. The second chapter is the development and application of the computational model for simulating heat space solid phase macroextraction of organic compounds from water. This research was aimed at developing more advanced CMP model of SPME of VOCs from water using porous coating RPDMS. And in extraction from water, 3 phases are involved with water, heat space, and fiber. And to model this process without agitation, diffusion of analytes in water, in air, in fiber, and distribution coefficient between water and heat space and fiber should be known. And when agitation is present, laminar or turbulent flow should be considered. And diffusion in water can be described by the Wilkie-Chang correlation. And for aqueous solution, distribution between water and heat space can be described using Henry's law constant, which can be defined using activity coefficient of each analyte. Mass transport, when agitation is present, can be described using flux of compounds, where exchange constants were estimated using 2 approaches in the model, Listen-Slater and Southworth. And as a result, simulated profiles without steering differ significantly from experimental obtained profiles because slow diffusion in water. And it means that steering plays an important role in the extraction of BTX from water. And also, the results of Southworth method were method to define the flux of analytes were the closest to experimental obtained profiles, and with root mean square deviation below 10% for all BTX at 25 degree and using 1000 RPM. And the developed model was used to study the effect of steering speed, fiber inception depth, and pressure on the extraction of benzene. And according to the simulated extraction profiles, to increase the steering speed from 500 to 1000 and 2000 RPM, decreases the benzene equilibrium time by 18, 11, and 16% respectively, and to increase the fiber reception depth from 15 to 20, 30, and 40 millimeters, decrease the equilibration time by 9, 25, and 38% respectively. Pressure decreases the benzene equilibration time by 83%. And to conclude, computational optimization of SPME for VOCs and water using photo squatting can be achieved with the southwest approach for exchange constants, Fuller method for air diffusion, and LZR for air coating distribution. This method yields RMSDs below 10% for compared to experimentally obtained profiles for LBTX at 25 degrees with using 1000 RPM. And third and last chapter is the developing an application of computational model for simulating heat space solid phase microextraction of organic compounds from soil. This study was aimed at developing of SPME model from dry soil using portal squatting and to study the mass transport from dry soil to heat space and to estimate the soil heat space distribution constants, bulk density, and tortuosity, porosity of the soil were used from the literature. And benzene was selected as a target analyte in this research. The effect of sample mass, soil heat space distribution constant, and distribution constant between fiber and air has been studied in this model, and also pressure has been studied in this model. And two coating heat space and distribution constant were studied, 150,000 and 8,300. As reported by Prikryl and Shevchik for CAR-PDMS and PDMS-DVB fibers, respectively, and modeling was conducted using 7 different values of soil heat space distribution constant from 1 to 1 million. And equilibrium time depends on both sample mass and soil heat space distribution constant. But vacuum has a substantial effect on the extraction of benzene from soil. And equilibrium in the system of SPME or benzene from soil with vacuum can be reached 43 times faster compared to traditional SPME at all studied distribution constants and sample masses of benzene extraction by CAR-PDMS coating. And to conclude, the presented model can be used for optimization of solid phase microextraction of all VOCs compound by providing physicochemical data. And to conclude the whole research, the computational models of SPME or VOCs from air, water, and soil has been developed using COMSOL multiphysics. And from air extraction using PDMS coating, it simulates VOCs extraction to optimize time under different temperatures, pressure, and vial geometry. And from water extraction using CAR-PDMS coating, optimizes stirring speed, fiber location, pressure, and vial geometry. And from soil, optimize sample mass, fiber location, extraction time, and pressure. Thank you for your attention. And I would like to express my sincerest gratitude to my supervisor, Dina Orazbaeva, and external supervisor, Yasik Adam Kozel. And I would like to thank for your co-supervisor, Bulat Kinesev, for the continued support, for sharing with unavailable ideas and advice, for Professor Levent Pelit and Fusun Pelit for their concern, and for supervision during my internship. And I want also to give special thanks to my husband and daughter for their moral support. And additionally, very thankful to the research group of the Ecology of Biosphere, and I appreciate the support of my research team members for their assistance. And please, if you have some question, you are welcome. That's all.
Thank you very much, Anel. Are there any questions? Please. Dear colleagues.
May I ask?
Okay, Gulay.
First of all, thank you so much for a very interesting presentation. My question will be, which, in your opinion, are the limitations of the study and how the future?
I'm sorry, but the end of your question was not...
I'm sorry. How these limitations can be addressed in the future?
Thank you for your question. Limit that we have that some physical-chemical parameters analyzed is unknown, and that we need to do some experimental tasks to determine these parameters. For example, form extraction from a it is unknown, the diffusion of analytes, not for some, but for mostly is unknown. Therefore, we need to do some tasks to determine the diffusion of analytes in fiber according to the fiber that we use. Also, the model about soil. Also, there's many unknown physical-chemical parameters of analytes, such as soil heat speed distribution constant, and also diffusion of analytes in fiber also is unknown. There also do not study the addition of water. So there is a lot of tasks that we, but the model that we developed allows to predict the optimal of SPME for the optimization of these parameters and disclose some errors during the laboratory tasks.
Thank you so much for your interesting answer. In general, I think that it's interesting how the estimation of some unknown physical-chemical parameters can benefit the modeling. And I'm thinking, what do you think that this kind of modeling can be performed for the newly synthesized fibers, which are not commercial?
Yes, of course, but is for example, if it's porous coating, we need to study the interconnect coating and pore size, tortuosity factor, all should be considered. Also, van der Waals connections also should be considered, and of course we can use it any new coatings. But we need to do some, I think, maybe at least a literature review what during the extraction.
Thank you, because I think it could be great to can greatly improve and the process of extraction on newly fibers, and in general to understand more the process of extraction, the modes, and so on. And can I have the last question? Which were the most interesting comments and questions from reviewers during the peer review process of your publications? Probably you remember the most interesting, compelling, which gave you the most some new insights.
I had a question from Bulat Uralbekov previously about the absorption. I mean that instead of heat of vaporization, enthalpy of absorption, we use heat of vaporization. It's like a task to do for the that for porous coating we should consider not of the heat of vaporization but absorption. So it's new things, new experiments. We know that we need to consider, but it's like additional experiments that we need to do and didn't do these experiments. But in future we will do, and we'll model a new we'll develop a new model with considering this parameter. I think that it also affect on the extraction. Also, you have insightful suggestion for the further researches because the effect of analyte conformation considering pore depth and shape has not been explicitly modeled, and integrating these steric effects could further improve the model. But I want to answer right now. And for PDMS fiber, we use diffusion of analytes in fiber that we considered the mass transport of molecules in the and for porous coating RPDMS, we consider the pore size, porosity, and bulk density that can describe the molecular transport and absorption.
Thank you so much for your answer. I actually, my question was about during the peer review of your publications, because I was reading in the materials of the work that some of the review process was a little bit difficult, and I was thinking, what if there could be interesting insights also, but also thank you for answering my question. I was not sure if it's really affecting, because I thought maybe this already was considered on the adsorption isotherms, but it was just for discussion. But thank you so much. It's interesting answer. Thank you. So probably you remember some interesting questions from during the paper submission, I mean. Maybe, yeah.
Yeah.
I'm sorry, maybe I did
Submission
not,
of the paper. Okay.
yeah.
Unfortunately, for the present time, I didn't remember, but I know that I provided some experimental task for a determination of different in fiber, because it was like comment from the review. In account of their comment, we provided some experimental research for determination of fiber.
Thank you so much. Thank you.
Thank you, Dr. Budaim. Maybe questions?
I have a question, but Professor Wujin, Professor Yusuf, and Professor Dan, and Snow. So you can ask any question about her presentation and dissertation. So while you were thinking about your question, I will ask a few questions if it's possible. Yeah, because I was a reviewer of this. And my first question is about your second statement. If you will show the second statement, your second statement is saying that increasing distribution constant from 1000 to 10,000 at constant temperature, and so you choose diffusion coefficient to 10 to minus 11, results in increase of equilibration time for 43%. Here I have several, for this statement I have many questions, but let's say starting from the first one. You say that increase of equilibration time, but it's not clear what is the starting point. Increase of equilibration time compared to what? So, yeah, this is the first question.
Mm-hmm. Thank you for your observation. Yes, for example, diffusion of analytes equal to 10 minus 1 multiplied 10 minus 9. 80% of equilibrium moment is extracted in 6.5 seconds. And to decrease this value to this, the increase is a five-fold increase in this time. You can.
I'm not sure you're right, because here you wrote that the increase from 46 to 66 seconds, yeah?
5.5 seconds to 36 seconds. Yeah.
6.5 or 5.5?
6.5. 6.5
6.5.
here. Look here. 80%, 6.5. And when 80% of the amount here, extrapolate to this will be about 40 seconds.
No, please be careful. As I said, in your second statement, you wrote, I want to know where is this come 43%. Could you give me
43% here. To KFA 10,000 at the same value of DF when decreased value, 43% increase in this time. Here 5-fold increase. Here less than 5-fold increase and only 43%.
Now, based on your statement, you have to say what was the equilibration time for 1,000 and what was equilibration time for 10,000. And then I can compare. Because from your statement, when you change equilibration time from 1,000 to 10,000, you have increasing of equilibration time in 43%. Yeah. So because now I see, for instance, if I will took 6.5 equilibration time for the distribution coefficient 1,000, and then to 10,000, it will not 43% increasing. You understand my question?
Unfortunately,
I will try. Okay, попробую. So I will try to explain to you in Russia. В вашем во втором стейтменте вы говорите, что у вас увеличивается equilibration time на 43%. Когда вы меняете константу этого константу distribution constant
Да,
от 1000 до 10 тысяч.
Да.
Я хочу увидеть, какое было бы equilibration time для 1000 и для 10 тысяч, чтобы увидеть, что у вас действительно увеличение на 43%.
Нет, когда увеличиваем от 10 до от 1000 до 10 тысяч, equilibration time при таких же значениях коэффициента диффузии в волокне изменяется на 43%. Вот при константе распределения 10
Я
тысяч.
понимаю, да. При одних и тех же коэффициентах диффузии, в частности, вы указываете этот коэффициент 10 минус 11 степени. Но я не вижу увеличения на 43%. Вот это я хочу сказать.
Ну вот здесь. Вот.
То ли я не могу понять, то ли вы не можете до меня донести. Вот эти два графика надо сравнивать. В первом графике должна быть equilibration time. И во втором графике должен быть equilibration time. И в первом графике я вижу у вас это как его...
А вы имеете в виду то, что мы не привели, то, что вместо equilibration time здесь equilibrium amount?
Здесь такая, либо я неправильно понимаю положение, либо вы его не доказали, я про это говорю. Вы в положении говорите, что у вас увеличивается ваше вот это равновесное время, ну или не равновесное, а как бы время, которое приводит к равновесию, увеличивается на 43% при изменении константы распределения от 1000 до 10 тысяч. Ваше положение я так читаю. И оно так вроде на английском написано. При одном и том же коэффициенте диффузии 10 минус 11.
Это объясняется так. При коэффициент распределения 1000 у нас вот при 80% экстракции происходит equilibrium amount is extracted in 6,5 секунды.
Так.
Когда уменьшение диффузии на 1-10 степени идет 5-кратный рост
Так,
увеличения.
это
Вот, а
понятно.
когда, да, 10 тысяч, разница при таких же параметрах
Давайте, Anel
увеличение
Kapar,
вот
once more again, let's read your statement once more again. Because it's probably, please read statements once again.
I think the statement is also on the slide. Okay. So yeah, it's different in here. Yeah, sorry.
Okay. Increasing the coating air distribution constant from 1000 to 10,000 at constant temperature, and the diffusion coefficient in PDMS equal to 10 minus 12 results in 43 increase of evaporation time.
Да, верно же. Увеличение до 10 тысяч при таких же параметрах.
Да. Так вот, вы мне скажите, сколько было при 1000, какое время было, и при 10 тысяч, чтобы я определил вот эту 43%. Я ее никак не могу. И так считаю, и так считаю.
Нет, это вот разница данных 43%. Вот 46 до 66 выросла, а при 6,5 и тут не видно мне. 32,6 секунды было. Здесь 5 раз выросла, а от 46 до 66.
Хорошо, по-другому задам вопрос. 43%. Можете мне это сказать? Как вы получили 43? На что поделили?
46 на 66.
46 на 66 делю. Получаю 69%. 46 на 66. 69,6%. 69,7%. Получается 43. Хорошо, Анель, надо чуть... Это нормально, это процедура защиты, успокойтесь, хорошо? So the next question is about when I was in seminar, I told you about uncertainty. So show me the slide when you modeling air SPMA. 31, да, вот здесь получается. А, нет. Где есть экспериментальная и это... Yeah. We have experimental data and modeling data.
About what chapter, please? Can you repeat
It's
again?
air.
Air.
The first chapter, okay?
Here.
Okay, here. My question is, what is the uncertainty and the error bar of these experimental points you have?
Error bars, because we made experiments only in one replicate.
Yeah, but even in this case, you need to estimate. I mean, okay?
Why we use replicate? Yeah, because my research were focused on the process, the whole extraction process, and obtain extraction profile. And here we used very extraction times, and that's when if we several replicates, few replicates, and that can disturb on the extraction profile on the results, because for example in 5 seconds the error bars can be higher than extraction. The error bars can be higher than 13%. That can affect on the extraction profile and the whole view, I mean. And also here used solid heat space solid phase macro extraction that can be used instead of validation, because last points are systematically consistent, and that results can be considered as reliable.
Okay.
Therefore, we
I have many other questions, but let's. I will leave it for the future. Let's say. Okay. Thank you.
I have a question. Well, I thought you did a very nice job in your presentation and also writing your dissertation. It was easy to follow, and I appreciate the details provided on your equations. One thing I wasn't familiar with is the application of vacuum to reduce equilibration times for semi-volatiles. Can you explain how application of a vacuum reduces equilibration time? That seems counterintuitive to me.
Do you mean theoretical part?
Yeah, how does
There's a process.
Sorry?
The process, you mean?
Yeah, how does putting a sample under vacuum, the air under vacuum, reduce equilibration time?
Thank you for your question. Actually, when the pressure decreases, the diffusion of analytes increase, and they can move, absorb on the or they can split, not split. They can inside the vial, for example, if it's a vial, equally and quickly, because the diffusion of analytes increase. So therefore, the vacuum positively on the extraction. And also, okay. Is it okay? Is it enough?
Well, I mean, it seems counterintuitive to me. When you apply a vacuum to a vial, you're actually removing analyte, right? When you pull a vacuum on a sample, you're pumping part of that sample out.
Yeah.
So that's the part that really struck me, is like, well, how does that increase extraction or reduce extraction kinetics? How does it increase the amount of analyte that you collect on the fiber?
Yeah, it's one against part. That's part of molecules can be transported to the vacuum pump. And here is a note about the vacuum time. How much time we vacuum the vial. For example, if there will be too much, all part can be moved vacuum pump. But if it's short, we have noticed that it's like not so much affected. Also, theoretical diffusion increase, okay, vacuum can positively, but we have another ways to decrease the effect of this vacuum pump. I mean that, for example, freeze the analytes before the vacuum. Yeah, for example.
Would it work? Would it help if you're extracting something that's very volatile? For example, vinyl chloride has a very low boiling point. So would it really help the extraction efficiency for something that's very volatile?
I mean, I didn't hear for what type of analytes.
Like vinyl chloride, which is extremely volatile. Would it really help the extraction efficiency and or kinetics?
It also depends on the distribution constant. If it's very high volatility and distribution constants very small, maybe vacuum will negatively affect. Maybe there's very quick absorption will be. We need to do.
That's what I
to-
think too, yeah. I think it may not help in that case. All right. Thanks for the answer.
May I follow up with Dan's question? That was one of the question I was reading. So with the when you apply vacuum, what parameters has been impacted in your model?
Can you repeat again, please?
Yeah, so when you do the model, you have the scenario that with vacuum and without vacuum. So when you apply vacuum, what are the parameters were impacted?
When we use vacuum,
Yeah. How does vacuum process impact your modeling process?
do you mean
Профессор-
in?
профессор Сон спрашивает, вы когда используете вакуум, вакуум, какие параметры влияют на ваше моделирование? Или включили ли вы это в моделирование? Спрашивает. Как вы учли этот эффект?
Pressure in the modeling were equal to 0.031. For example, if pressure equal to atmospheric pressure, if it's 1 atm, then under vacuum pressure was equal to 0.031. It's like minimum minimum value under vacuum conditions.
So does it impact your diffusion coefficient, or you just
Yes.
use that to change the parameter? The
Yes.
the pressure is a parameter that you are changing, and you don't change any other parameter.
Not only pressure.
Not only pressure and other parameters are you changing?
Not only pressure when of analytes in air were calculated.
Yeah. So may I continue ask a few questions? I'm very interested in reading your dissertation. It's very nicely done. And I really enjoy that you have 3 different scenarios. And I'm more from the modeling perspective. I don't really do like Dan is really know how this experimentally work. So I'm more on the modeling side. I have a few questions. I'm just feel a little bit of the clarification. So first, I find that so the air part, the air sample is very clearly modeled. It was really nice. And then when I read into your liquid sample, and it could be I misunderstand. So when you model the liquid sample, you considered that the adsorption isotherm for the media is porous. So after it get into PDMS and get into your actual fiber, it's a porous media, and you can see the adsorption over there. I didn't see you have that in your air sample. Is that 2 different setup? That part I don't fully understand.
Yes, absorption of the term in the fiber does not include but because it has been studied before my research, and we just uploaded that part that studied the term in the fiber into the for further research for my dissertation or for my thesis.
Okay, I don't fully understand. So you said
I didn't like study, did some experiments for absorption of the term in porous coating because it has been taken from previous researches that.
So you did, but you did you consider the
Yeah, in the
absorption?
model, it's of course considered. It's a included in my thesis here in my presentation because it's like not part that I researched. I just from previous research I just adapt it into my model in the modeling.
Okay,
But
so okay. So you have sorption in a porous fiber on both models. It's just the first one, you know the parameter already, so you didn't include that. Is that what you mean?
yes,
The second one, you need to establish the parameter. I still don't fully understand. So you consider both, but just didn't write that in the dissertation for the first one.
w- I didn't match your question. Sorry.
No, yeah. Yeah, so my question is, I didn't understand that you have the sorption considered for the liquid sample and for the solid sample later on. But I didn't say you include in the air sample. But then later you told me that for the air sample, you also included that in the model. You just didn't write it down. Is that what you mean?
Maybe you're about distribution of molecules between water in heat space when they absorb it from the water to heat space, from heat space to fiber. Inside the fiber, do you mean that?
Yeah, I
Because
mean inside the fiber. Yeah, I mean inside the
inside the
fiber.
fiber for porous coating. In water, we use porous coating, and this is a term like just taken from previous researches. Considering the porosity, tertoicity, and bulk density of the porous material.
So Professor Yusong, she took this experimental data from previous publication.
Okay. Okay, so mechanisms were considered, but it's just the parameter. You use the parameter from the previous studies. Is that right? For the
mechanism will be the same, yeah.
okay, that partially answer my question because what's the difference for the water sample, the solid sample or air sample in terms of the sorption inside the fiber? Because none of them, they both are, they are all is going from air across that coating and getting into the fiber. So when you get into the fiber, I don't think the sample type make any difference.
Distribution coefficient
Yeah.
from water to heat space, from soil heat space of analytes are different, and different computational estimations. For example, for air, for water, from air, from water, from soil extraction. From soil, we have only like base model to predict the optimal parameters of SPME in the range between soil heat space distribution constant from 1 to 1 billion. In one soil heat space distribution constant were for in water mass transport in as the flux of compounds, where exchange constants to define the flux were using two approach here.
Yeah, so I understand the systems are different, but I was just asking about the sorption inside of the fiber. That process, I don't see difference between, so they should be the same that particular sorption step. They are the same, no matter what type of the sample you are, right?
There is.
I mean the
coating,
parameter.
We distinguish porous coating and porous coating and non-porous. I mean that for polar compounds and non-polar compounds. For example, carpe diem use it in extraction from water. There's like absorption as a term that considers the porosity, bulk density of the carboxyl.
Okay, just Doctor Professor just I will just a little bit translate her into Russian, so then he can catch the question. Она спрашивает, когда вы из газовой фазы вытаскиваете из почвы или воды, у вас, скажем так, сорбция же одинаковая, то есть для газовой фазы, чтобы было для воздуха, для воды и так далее. Вам надо сказать, скорее всего, что то, что вы для атмосферы получили, вы потом его использовали для воды и для почвы. Именно эту часть, когда у вас сорбируется, то есть когда у вас органические вещества переходят. То есть она спрашивает вот этот процесс сорбции из газовой фазы в SPMA один и тот же во всех трех сценариях или нет?
Извините, мне кажется, она... can I ask again, can I interpret the question? I think the question is of Mrs. Lee is why there are different absorption processes or different fiber mechanisms for air and water and soil, because they were different. So in air, there was another type of fiber, and then for water there was another type of fiber. Why was it so that they are different? Is this the question?
Kind of. So I started with thinking, are you using different fiber for the different sample? Because I noticed that you consider the absorption for the air sample and the air sample and water sample, but not for for the water sample and the solid sample, but not for the air sample. So I think it's probably just how the things that you write down are not as consistent, I feel. Sounds like you considered this absorption for all three. It's just you just didn't write that step. I didn't say you write down the step for absorption inside fiber. Absorption inside the fiber should be the. I don't understand why it's different. That absorption inside the fiber, because you have the molecule diffuse across the coating and getting to the fiber, and then that absorption just happening for those molecule between the molecule and the porous media in the fiber. So it wouldn't be different when you use this instrument to measure the air sample or water sample or soil sample, right? I feel they are the same, but you should include all of them. So I'm fine as long as you included all of them in the model, but I just feel you need to write down.
Ну, по-моему, как я и сказал, все-таки, Анель, это вопрос такой. Вот вы то, что вы использовали результаты при моделировании вашей газовой фазы в SPMI, вы использовали эти результаты, а именно оптимальные условия при моделировании, когда вы из воды и из почвы.
Ну, там же другое волокно, пористое. Там даже в комсоле есть значок, где указывает, что это пористое вещество, на которое...
Да, я думаю,
и у него запросы...
Все понятно, вы же его...
Расскажите разницу между волокнами.
И у вас же, я так понимаю, вы это волокно сразу же в воду... А, нет. А тогда с почвой, вы же в почву-то его не этот... Вы все равно, у вас одно из процессов, это все... У вас же сначала... Вот если возьмем воду, вы сначала из воды же в газовую фазу переходите, правильно? А потом
для
из газовой...
волокно использовалось, не такое, как для воздуха. И вот она говорит
Тогда
о том,
вопрос, вы использовали ваши результаты, когда вы оптимизировали результаты, которые вы получили по воздуху при моделировании тех процессов?
Okay, I think that I understand.
So, Professor, can I just add additional question to Anel? I'm very thankful for the interesting presentation, Anel. Well, here I have just one very simple question: how you guys want you actually simulate the system? So I just want to know the boundary of the air sample and water sample and also solid sample. So maybe you can do the just a direct suction method for the air sample, just a, just a suck in the sample, and then you can do that. But for the water sample, for example, in the water with the benzene or all types of the volatile organic chemicals, maybe you can use purge and trap method, and you can use headspace method, and even vinyl chloride boiling point is -8 actually Celsius. So if you just crack down the ampule, it just disappeared. So maybe you can use such kind of the sample preparation method, and solid sample. Do you do Rickett extraction or succinate or something like that, and then injecting into the GC-mass? Is that the boundary you simulate using the mathematical model? If so, well, as Professor Lee said, I cannot see any differences between the water sample and also solid sample. So could you just specifically explain about the boundary your system you want to simulate? That may be very helpful for my understanding.
Thank you for your observation. In the model, the absorption from about the extraction from water and from soil, there is no difference.
Oh, okay.
Only one fiber were used for extraction, and the physical chemical parameters and mass transport in the fiber were equally because only the same fiber is used in both extraction and from soil. And from air, it's a different fiber, and therefore the diffusion analytes in the fiber were estimated.
What about the sample? So sample, how do you simulate the system? So is that the water sample and the solid sample preparation procedures or similar? It couldn't be similar, right?
Yes, it does not simulate. The absorption of analytes is can be heat space. Like analytes, it's not direct immersion of the fibers that should be considered in water, for example, or in solid extraction. In both, the extraction from a heat space.
Okay.
Of volatility of analytes and mass transport analytes from differently from water to heat space and from soil to heat space. But the final extraction is from a heat space.
Maybe I'd better put some.
Therefore, the process mass transport of analytes are different from water and from soil, because they are both moved from soil and water to heat space, and the process from heat space is equal already for both.
Okay, I think I'd better put my comments on your, on your dissertation, directly. That might be much helpful to you. Okay, thank you.
Thank you.
May I ask one more question? I really enjoy reading your dissertation. So the part that I wanted to know more is how for the agitation situation when you have water phase, water sample, how did you couple? Because you said you used a turbulent flow module in COMSOL. How I saw that, but I didn't really get how did you couple the result of that turbulent flow module with your mass transfer process?
Do you mean steering? Yeah, I think steering, when a steering present, oh, only southwards approach considers the steering recurrent by estimating. In the recurrent, we used steering.
But that was I studied by thinking you use V current, but later on I found somewhere in your paper that you use a 2 pi RS to estimate your V current.
Yes. The current equal to 2 ps. Yeah.
So S is the agitation. So which component is from the turbulent flow module?
What do you mean?
I think in your dissertation you said you used a turbulent flow module in COMSOL to simulate the water agitation process.
Yeah, it
So
means that we used steering when steering is present, when agitation is present and agitation is considered in the southward approach.
yeah, so my question is what did you use from that? Because in the southwest, the parameters are here. M is the like agitation rate, right? And then this V current is you calculate by 2 pi R S. What is that S, if you don't mind, remind me?
I'm not sure, because I but S it maybe like the diameter in the lab because process.
No, S is a stirring rate. I found from your dissertation on page 57.
Sorry.
Yeah. So nothing is from that turbulent flow module. What does that turbulent flow module give you? Because
instead of turbulent flow, we consider it agitation.
okay, so you didn't actually use the turbulent flow module to do simulation.
Yes, but we consider it agitation instead of this.
Это одно и то же, Анеля. Просто разными словами говорите.
Did you use
Yeah.
turbulent?
Yes.
So yeah, so my question is, what is that turbulent flow do? How do you couple that with your mass transport process? What did that turbulent flow give you?
Increasing of diffusion or increasing of mass of analysis.
Yeah, how did you couple it? What do you get out of that and couple that with your mass transfer process?
Like increasing of molecular interactions.
Like how? So because typically when you
couple to each other and how to say distribute quicker distributed in account of interactions.
Sorry, can I interrupt again? I think the question here, is how, so this your southward approach, how is it used in the mass transfer equations of your model? When model it's its input into the mass transfer equations.
Yeah. So it's not just the southwest. I think what Anel answered kind of makes sense now. Southwest was because you don't really need any turbulent results for the southwest. You have all the parameters here. You have you can calculate the velocity based on your agitate rate. But your turbulent flow, because when you do the simulation, for example, when you simulate transport, you have mass part and you have the flow part. Then you couple them together. So I really wanted to know is how did you couple the mass part, the molecular movement part, with that agitation, like turbulent part? How do you couple them? What parameters you use. In the simple laminar flow situation, you would use the velocity there and couple with the mass flow. So you will not just have the diffusion, you might have like dispersion, any other thing. So in your situation, what was that couple over there for the turbulent flow?
Steering speed. We use steering speed. Different steering speed.
You know what speed?
Steering speed.
Steering speed.
Magnetic steer bar in while, and that's all. We use
But
steering speed.
and the steering speed is do you mean steering speed is your output from the turbulent flow, or is your input from the experiment that you know what's your parameter, or is the output?
I don't know which how this process occurring during this turbulent flow, because didn't deeply but I think that this is
Yeah, I mean, you don't have to know the detail of the turbulent flow, and I'm not an expert on that as well. But I think you need to be pretty clear on what is the output that you have been using. COMSOL probably couple that for you. You know, you choose and then you couple. But which part did you use for that turbulent flow helped your process, your modeling process? I feel that you want to be clear on that. You don't need to. Turbulent flow is very complicated. You don't need to know. But what parameter change on that turbulent flow will impact your results? Because I think the steering rate is something your input and not output. You know your steering rate from the beginning.
is that the diffusion of analysis increase.
У вас, вы когда вот
Mass
этот вот,
transport.
она спрашивает, вы когда эксперимент проводили, вы знали, вот этот steering rate, вы знали или не знали? То есть это входило в вашу модель как input, или же это как output, который вышел из модели?
This is input. We already know it before, knew before that what steering speed we will be.
Да, и тогда ее вопрос, в какой формуле это, где это в формуле входит вот это вот?
So where in COMSOL you use to input the steering rate, this RPM?
When mass transport, to define the flux of compounds here, in southwards we used steering speed by current, and then to describe the mass from water to heat space.
Yeah, I think you're fine. You just wanted to get back when you look at this to know, like, make it clearer. What did you use? You can just get into your COMSOL project and you would know how you couple those two together. Yeah. And I think Southworth is good that all the parameters that you know, which parameters you used. So mass transport part is good. Yeah. Yeah. Thank you.
Thank you.
Chairperson, if I will have one last, no, not last, but question which arised during discussion. My question is about, in short, really brief. I see that you already, but because this is dissertation and we want to know your qualification, and you actually investigate PTEX or TEX, like it's about 4 compounds, yeah, benzene, toluene, benzene, and xylene, probably, yeah.
Yes.
Have you found the different behavior when you modeled these 4 compounds? Yeah,
The difference is about the collaboration time. It's different for all
probably.
compounds.
Yeah, equilibration time.
Mhm.
Yeah, so
Yes.
you found some, but my last question about this second statement, which I not finished. This second statement is not trivial, or because we see that you change the distribution constant. Why when we improve distribution constant, we have an increasing of distribution time. Can you explain why when this distribution constant increased, we have increasing of the equilibration time? Do you have any idea why it's happened?
Yes, because when when distribution constant is very small, the diffusion of analytes is big. So collaboration time is faster when it's small and when very big. So it's about the absorption of analytes and in the heat space and absorption into the
Yeah. So based on this,
fiber.
how is this statement is according to the rule? Because if we can predict, yeah, if you can predict, so the statement should be like we cannot predict using some law. I mean, if you can predict that increasing distribution coefficient, we can increase time. So the statement can be. I mean, this is just for the probably future work. Yeah, you have to. It should be. I told you many times that you have many statements. It's better to have 1, 2, or 3 statements, and I mean, and the news. Okay, Chairperson, I also finished with my question.
Okay, may I have some questions also? Maybe just to clarify some things, I will try to ask like a shorter questions. What's the physical meaning of the flux in this case?
Mass
How do you
transport.
understand flux?
Mass transport from a wide space. Distribution of analytes. Distribution of analytes from water to heat space. It's law constant, sorry.
Okay, what are the units of flux?
KL. It's like a flux dimensional scale is law constant. Yeah.
No, I'm asking about flux, not the KL. What are the units, dimensions of flux?
There's no units.
Yeah, flux has units.
Yes. Sorry, I cannot answer on this question.
Okay, so, but if we increase the steering speed, the flux increases or not, or decreases?
Okay. Decreases.
Why?
Because here it's like flux is proportional to KL. Sorry. Flux also decreased because here one is changed. Flux because here KL can be proportional to proportional, but can proportional to the velocity on the steering speed.
But actually it depends. When you have the extraction, so it should increase. So if you have higher agitation speed, the V current
Flux of compound.
increases,
Yes,
and then
we
KL
can.
and KH, all of them increase. So and this KL should increase.
Yes, should increase, and flux is proportional to KL.
Okay, and another question: what's the difference between PDMS and carboxyl PDMS fiber? Internal structure of these fibers.
It's a port like absorption for PDMS on the fiber coating. For car PDMS inside the coating.
Okay, but what do you have inside carboxyl PDMS fiber?
Particles, 1,000 particles or carboxyl.
Only carboxyl particles?
Yes, inside carboxyl particles. No, yes, inside in carboxyl particles and PDMS. Outside.
Outside of what?
Actually, on this question like that. Differences between PDMS and car PDMS coatings are that car PDMS for polar compounds, it's PDMS for non-polar compounds. Because it's about the porosity,
Okay, what is inside pores?
Particles.
No, inside particles, what do you have? Inside particles, you have pores.
Mm-hmm.
Yeah. The pores, what do you have?
It's maybe about the size of particle, size of pores. For example, in carboxyl, car PDMS, there's a little bit bigger pores that should consider the porosity, tortuosity, physicochemical parameters.
No, what chemical compound is present inside the pores?
Carboxyl?
Yes?
Yes. Polydimethylsiloxane. It's like.
No, it's air.
Inside.
Yeah, or if you have vacuum, it's not air anymore. Okay.
Чего нет?
Okay, that's all for me. Thank you.
Thank you very much. I think maybe enough questions.
I have one question. Can I ask?
Okay. If you have.
Anil, I want to ask about maximum permissible concentration of these organic compounds. Are you check it or not? Maximum permissible concentration.
For what purpose should we consider?
На русском ПДК.
Да, я поняла. ПДК. Мы не проверяли ПДК.
Не проверяли.
То есть у нас же нету, мы нигде это не исследовали на реальных образцах, чтобы измерить ПДК. Только построили модель. компьютерную модель и сравнили это с экспериментальными данными.
Просто компьютером. Хорошо. Просто если вы взяли только бензол, это толуол, но там тоже есть же другие вещества органические. Можно было тоже их посмотреть. Второго класса, третий, четвертый класс, который относится, нужно было. Хорошо, ладно.
Хорошо, спасибо. Thank you for the questions. There are no more questions?
I have
So,
one last, if it's okay, I'd like to ask one more question.
yes, it's okay. Please.
Have you heard the phrase, all models are wrong, but some are useful? No?
I
It's
haven't heard.
yeah, it's from a statistician, George Box, published that in 1976. And the point of that statement is that it is really true. All models are wrong. Some are useful. And I'm not a modeler. That's why I invited Dr. Lee to join the committee. It's important to keep in mind that a model is just a simulation. It's based on lots of assumptions, and it may or may not provide useful information. So I just want you to keep that in mind. There are lots of ways to simulate real systems. They're all wrong.
Okay.
Okay. All right. Thank you.
Thank you.
Ну, он спрашивает, согласны ли вы с этой, как его, что все модели это как бы wrong. Буквально пару слов скажите, что согласны или нет, или как бы они нужны.
But of my opinion, I think that's it's a good to disclose it. Like this is not final point. This but before the experiments to cut the time for the experiments that should be done. It's like a good way, opportunity to disclose the possible errors.
That's all I have.
Thank you. Thank you very much. Okay. Are there no more questions? I hope. The floor is given to the scientific supervisors. The first supervisor, Rozbaeva Dina, PhD, senior researcher at the Farabi Kazakh National University. Please.
Thank you. Thank you, dear dissertation council, and to the reviewers. It was really a very thorough review and nice questions. I think it was as hard the work was because there was a lot of experimentally based, I mean, the practical questions on extraction as well as the modeling questions. So it was a very complicated task. And it was, to be honest, it was so complicated even for me as a supervisor. For the entire research team, it was a very challenging task and research. And I think I would like to ask from you some not maybe a slack, but some maybe a kinder, gentler approach to Anel because she's been probably really stressed by the end of the discussion, and it's been partly maybe because she has completed the work more than a year ago, so some of it is already something in the past. But we will address these questions. There were really nice questions about also the statements that we need to still maybe correct if we can do that even after the today's defense. Because yeah, we saw again some maybe minor, I'd say, still incorrect formulations of the statement. And yeah, I highly think the comments from Professor Lee on COMSOL models. These are really insightful. And but however, I fully support Anel's PhD work. I think she has completed and has made her her input into the research at the level appropriate for the PhD candidate, and she deserves to. I think she fully deserves the degree based on her journey as a researcher, her work on both experiments and models and papers, and she's already a aspiring young researcher. So I thank you for your interest in her work and kindly ask you to support her application for a PhD degree. Thank you.
Thank you. Thank you very much. Okay. And second supervisor is Jacek Kozel.
Yeah, may I read a review from Jacek Kozel because he's absent.
Okay,
And
yeah.
Dr. Jacek Kozel provided his review letter of Anel Kapar, and I will read very briefly on important issues. And Jacek Kozel is a professor from Department of Agricultural and Biosystem Engineering from Iowa State University, United States of America. And he said that Anel's PhD thesis is a compilation of several chapters that are logically separated. And Anel's publication record is similar to average compared with expectations for the typical PhD students in his university, where 3 peer-reviewed publications are norm, but student can defend thesis without all papers published. So he's pointed that Anel has published 1 paper as a first author and made major contribution to the rest peer-reviewed papers. Anel is excellent chemist, is very well prepared to defend her thesis. And in summary, he is very supportive and pleased with Anel's progress towards earning a PhD degree. Yeah, thank you.
Okay, thank you very much. And now we wanted to give the floor to the reviewers. The first reviewer is PhD associate professor, chief researcher of the engineering profile laboratory physical-chemical methods of analysis at Corkut Attack University. Please.
Thank you. Review for dissertation of Kapar Anel on the theme modeling the process of solid phase microextraction of organic compounds from environmental objects. Submitted for the degree of Doctor of Philosophy in the educational program chemistry. The topic of the thesis corresponds to the directions of development of science and the state programs. The thesis was completed within the framework of a project or target program financed from the state budget. Importance for the science. The work makes a significant contribution to science, and its importance is well disclosed. This research enhances the understanding of the theory of solid phase microextraction (SPME) by employing computer simulation of optimization of SPME parameters. Computational models were developed to simulate this SPME process for volatile organic compounds in environmental samples. These models enable the optimization of SPME conditions, improving extraction efficiency and significantly reducing analysis time, thus contributing to the advancement of analytical methodologies in environmental science. Practical value principle. The thesis has theoretical value, yes. The thesis aimed at DP understanding the mechanisms and the process taking place during SPME of various compounds from air, water, and the soil. The quality of writing and the design. Academic writing quality high. Notes on the thesis. Despite numerous advantages, the remarks as follows. In chapter 2, the effect of humidity on extraction process was not discussed. The humidity also was not described in modeling parameters. In chapter 4, the simulated extraction profiles were not compared with experimental data, as in previous chapters and the samples. For experimental data in chapter 3, there are no error bars. The decision of the official review. This thesis on the topic modeling of process of solid phase microextraction of organic chemistry compounds from environmental objects submitted for the degree of Doctor of Philosophy is a complete study with reliable discussed scientific results. The work meets the requirements of the Science and Higher Education Quality Assurance Committee of the Ministry of Science and Higher Education of the Republic of Kazakhstan for dissertation for the degree Doctor of Philosophy in the specialty chemistry and can be awarded the degree PhD. That's all. Thank you. Ahmed.
Thank you very much, Nurgali. Окей, Анель, ответьте, пожалуйста.
Thank you for your notes. In chapter 2, we did not computational models for humidity, but ensured the constant humidity during all experiments. For example, it had been used solid granulars to minimize variations and maintain stable lab conditions. And distribution constant between fiber and air were estimated specifically for the measured humidity, such as 50%. About the second note, in chapter 4, the experimental data were not included because the model is intended for predicting the optimal parameters of SPME, not as a final analytical tool. And many unknown parameters such as soil heat space distribution constants, addition of water requires some experimental work to determine. And despite this model effectively predicts the optimal parameters of SPME development, providing a useful starting point for the future research. And about third, that there is no error bars. And the main is to observe the extraction process at a given temperature, as I answered before. And since the extraction reaches the plateau, points are systematically constant and unchanged, the results can be considered reliable. Also, we used multiple heat space solid phase microextraction. That's all.
Thank you very much. Nurgali, is it enough for your question?
иә толықтай келісемін айтқандарымен. Рахмет.
Okay. The floor is given to the second reviewer, Sagandikova Guleem, PhD, postdoctoral researcher at the University of Tübingen.
Thank you. Thank you. As I already told, that the study is highly interesting in my opinion. It's performed with outstanding quality. The goal and methodology are highly innovative. Especially, particularly innovative aspect is application of gas inverse chromatography for estimating of diffusion coefficients of analytes. Also, study clearly demonstrates that Anel is a well-prepared young researcher, ready to start her scientific career. Also, since this such research requires strong theoretical foundation, it reflects her solid educational background. Also, I would like to say that I highly appreciate such kind of studies dedicated to modeling of extraction, since they can substantially reduce the time for optimization of extraction. Of course, not replace. This was not the goal of such simulations, but to reduce the costs and time needed for optimization, and also gain insights into mechanisms of extraction, which always contribute to the more efficient use of extraction for different samples. Of course, there are many assumptions are made, and always there are limitations in each simulation, but in my opinion, such work and development is in our university, in Al-Farabi Kazakh National University, in general, in scientific community is important step, and really much appreciated. I did not have the major questions to candidate, only for scientific discussion. I was interested if the depth and shape of pores and molecular configuration of analytes could be considered, but Anel already answered to this question. So my decision was to award the degree, and I'm sure that Anel will consider all comments in her future research, and I hope that she will continue her research in future, and I wish all the best, and thank you so much for your presentation today. So I think this is all. Also, I would like to, maybe we could, I mean that I think that in my opinion, all provisions were proved. And my calculations of 43% are also the same. I mean, since like from 66 to 46, I mean, I also calculated as 43. So in my opinion, this provision was proved. Thank you.
Thank you very much, Dr. Guleem. Okay, as I understand, you don't have critical opinion. Anel, what you can add to words of Dr.
Thank you very
Sagandikova?
much for your review. I read the comments that you did, and will try to in the future and include include it for further researchers.
Thank you, thank you.
Thank you. I just wanted to add that it's not like I do not have critical opinion, but I just think that the work was done really with outstanding quality, and it was a pleasure to read the work. Thank you.
Okay,
Thank you very much.
So, dear colleagues, we proceed to the discussion of the dissertation. I think Guleem was first. Yeah. Who wants to add something?
So I will start a discussion. So this discussion panel is open, and then we can tell about work, but without saying how we will vote. Okay.
Yeah.
This is very important. The reviewer said that 43% she calculated, but I will now, of course, believe reviewer. But because otherwise, the most important issue, each results you get, you have to prove. Okay, so 43% is obtained like by dividing this to this, and then so because you are defending this and statement, and I don't. Let's say I will believe review. Okay. What I want to say is water modeling is quite developed by the candidate NVC. Sorry, air modeling. We see that it's quite developed, but then we go to water and it's less developed, and then we go to soil, which is really less developed. What I would like to say, probably it will be enough if you will only modeled air. No? You see, for the PhD, it's my opinion, but for PhD, if you will be modeled air and will be know each details there, so it will be good. Then taking all these media and all these models, but not to know it details. But in the future, take one small problem and be an expert on this. Okay, this is my how to say suggestions, because it's quite difficult to take into consideration all the inputs for models and then to validate this model. This is quite difficult because the next question is the validation of model, yeah, which I see in your thesis quite poorly presented. I mean, the validation of the but when I read your thesis, I see that you did a lot of work, a lot of research, a lot of studies, which then you published in a quite higher peer review paper. Analytica Chimica is quite a good journal, so it's quite a good research. So your work quite impressed me with regards of obtained results, published proceedings, and my suggestions I said during my questions and during my review of your thesis, and then I think that in the future you will take all these comments or part of these comments into consideration, and hope that you will continue, because as Professor Snow said, not he, but he mentioned all models is wrong, but yeah, you answered that quite a good validated model will help us to save time. Okay, so thank you. This is my but regarding candidate, we see that candidate know English in a very well level, which is because her English is not native, and we see that she understands fluently in English. So this is a very good point. And then the second one, Anel Kapar is a quite smart student in our chemical department. So, and I wish all the best. I mean, to Anel. Okay. Thank you.
Very much.
Thank you. Thank you. Who else?
I can say a few words, Anna. I give you a hard time during the question session, but I think you did a very good job. Those are very complicated models. very hard work. I know it's hard to get things all together, and you did both experiments and modeling, both together and integrate them together. That's really good. I just 100% agree with Dan, and I also always tell my students, no model is correct, right? It's you have a lot of assumptions over there. You simplify the system. Always keep that in the mind. My recommendation for your future work, I think you want to form a habit to always think about very clearly lay out what are your assumptions of this model, what are your initial conditions, what are your boundary conditions. I think it would make a reviewer understand much better, and it also help you for your work. It's much cleaner, would be that way. So that's all I want to say.
Thank you very much. Thank you.
Thank you. Thank you very much.
I'll just say a couple of words. Yeah, I was very impressed with the dissertation. I think you did a lot of work and accolades, especially on the quality of the writing. It was easy for me to understand, so I could tell you had put a lot of effort into the writing, which is not something I always see in student dissertations. And then I agree with Dr. Lee. When you use a model, it's important to look at it from the perspective of somebody who doesn't do modeling and start with explaining the fundamentals and articulate the weaknesses of the model. So there's always weaknesses that can be exploited. There's always assumptions that go into every model that must be described and then acknowledged when you interpret your results. So great job. I was very happy to be part of this committee.
Thank you very much.
Thank you very much. Bulat Nurlanch, maybe you want to add something because it's your topic too, and you know about this work.
Yeah, but I'm a little bit also affiliated with this research.
Yes, but maybe about work.
I would just try to comment on the second statement for the difference, and I agree that it was not proven. In the article, there is a different statement proven. Yeah, so it says the difference between diffusion coefficients, not the partitioning coefficients. Yeah, so it's, or at least we didn't see the evidence for the statement. This is also maybe if you see the evidence, I would say something different, but we didn't see it.
Okay, thank you, because it was my brief announcement, but please be careful next time, and thank you for these comments, Professor Denisov. And yeah, so we have Eugene Lee, because he is Professor Lee is quite need to, and all other members need to to go, because if we will a little bit proceed our procedure, so Dr. Elieva, and because now we have probably 3 hours. What depends.
Okay. So I can go to the secret ballot.
Yeah, it's a secret voting. Yeah, it's secret voting
Yeah.
procedure, and Professor Kinesov, he can help us with this procedure.
Okay, so dear colleagues, now I will move the PhD student and supervisor and other non-voting participants to the waiting room. So please do not disconnect from Zoom, and we will return you back after we finish the voting. So just a second. Okay, and now I will also connect from another account because I cannot vote from the main account where the voting is started from.
Recording in progress.
So, dear colleagues, you will now see in your screen the voting choose. So you can just choose in your screen. Okay.
Okay, this is also me. Okay, you will see it on the screen, and please vote only once, and everybody must vote. So we have 9 people, and we should have 9 votes. Just a second. Okay, now it's ready.
Кешіріңіздер, бізде дауыс береміз бе, рецензенттер?
Yeah, міндетті түрде.
Yeah, you also vote. Reviewers also vote.
Шықты ма неде экранда?
Yeah.
Онда. Хорошо.
So we need one more vote. So 8 people voted.
Professor Lee, have you?
I voted.
Okay.
Okay, now everybody voted.
I did.
Okay, thank you.
Okay, so now everybody voted. And I finalized the voting. And I need to return everybody. Okay, dear colleagues, everybody is back. So should I show the results?
Yes, please.
So here are the results of the secret poll. Do you see it?
Yes.
Okay.
Okay, I think all members can see. For the award PhD degree, 67%. I think that, as I know, it's not enough. Yeah.
Yeah, it's not enough. We need 75%. Okay, now we should have the second round of poll with only 2 options. Send the dissertation for revision and send the dissertation for redefense. Okay, I need to start
now
this.
we vote again.
Yeah, just a second. We again need to move to the waiting room. Okay, and I will just find another poll. Just a second. Okay, so now I'm ready to start the poll, secondary poll, with two options. We need one more vote. Okay, we are ready.
Влад Иванович, кажется, меня не убрали из списка, кто может голосовать.
Okay. So now you can, we finished the voting. Yeah. Now we are ready to show them. Okay. Do you see the results?
Yeah, we see the results and based on the results of secret voting, dissertation council at Al-Farabi Kazmo sent work to the revision.
Yeah, so based on our rules, we will have another meetings when the candidate will change minor revision in her thesis, and then we will meet once more, which is a very good news. So I'm asking the temporary members and reviewers to write to the dissertation council short notes and recommendation which you found during the thesis. Okay, so then the candidate can change it, and then we can evaluate these changes.
And time?
Regarding deadline, I don't remember, but it's
Deadline, yeah, during several months. I don't remember exactly.
3 months.
3 months.
Yeah, so during 3 months she need to change all these comments and recommendation arised from the dissertation council.
Anel, are you here? Anel?
Yes.
Because we don't see you.
Thank you.
Okay. So in 3 months, you can present the dissertation, and then if you need, you can then prolong it for 3 more months if you need.
Sorry, can I ask a question on this? So Anel would have to provide the changes and revisions according to the comments of today's dissertation council and reviewers, right?
No. It's we will dissertation council provide you a list of comments and recommendation to change and improve the thesis. So she need to point by point to. It's a kind of like when you have a review from paper. So you will get the same comments from dissertation council. Yeah. In a. Let's say
And then the next meeting, it's the same
Procedure, no.
Yeah, the next meeting is on the evaluation of changes, okay?
Yes, without Anel, only dissertation council will be show results.
Oh, I see. So she only needs to provide the written answers to the comments as well
Yes.
as the corrected thesis dissertation.
Да, это просто корректировка работы, это не отрицание условно результатов, просто доведение до
Финальный.
идеала назовем.
Тогда, Алина Кульбаевна, вы тогда это результат огласите, чтобы у нас как-то хорошо?
Да, ну вот я еще раз туда повторю. Based on the secret online voting, the dissertation council at Alpha Arabic Kazno sent dissertation of Kapar Anel on the topic model in the process of solid fast microextraction of organic compounds from environmental objects, sent to review for revision.
So, thank you all. Dr. Yusang, Dr. Professor Snow, Dr. Lee, Professor Lee, thank you for your time.
Thank you very
Yes.
much. Well,
Thank you very much
time
for
indeed
attentive.
See you next time. Thank you.
See you.
Thank you.
Thank you. Bye.